You've got a $5 VPS with 1 GB of RAM, and you want to run an autonomous agent on it. Can you actually pull that off? Or will your framework choice quietly eat every megabyte you've got? That question decides whether your project runs smoothly or crashes at 3 in the morning under a memory spike you never saw coming. Here's the setup for this test. I provisioned 2 identical budget VPS instances, 1 virtual CPU, 1 GB of RAM, running Ubuntu 22.04, the kind of box you rent for the price of a coffee. On one I installed LangChain, on the other CrewAI. Same task for both. A 2-agent workflow that researches a topic, summarizes findings, and writes a short report using the same OpenAI model over the API. I measured cold start memory, idle footprint, peak usage during execution, and how each one behaved when I pushed concurrent requests. Let's start with the raw import cost, because this matters more than people expect. Just importing LangChain and its dependencies pulled the Python process up to around 180 megabytes before a single agent ran. That's the tax you pay for its enormous ecosystem. Dozens of integrations loaded through a sprawling dependency tree. CrewAI, which is itself built on top of LangChain components, landed slightly higher on import at roughly 210 megabytes, since it stacks its orchestration layer on top of what LangChain already brings. But import cost isn't the whole story, and this is where it gets interesting. During actual execution, LangChain's peak memory settled around 340 megabytes for the 2-agent run. CrewAI, because of how it manages its crew objects, task queues, and inter-agent context passing, peaked closer to 430 megabytes. That extra 90 megabytes is the price of CrewAI's higher-level abstraction, the role-based agent model that makes it so pleasant to write costs you real memory when the crew spins up and holds all that state in parallel. Now push concurrency, and the budget box starts sweating. When I fired 3 overlapping requests at each framework, LangChain stayed alive, but slowed noticeably, hitting swap and dragging response times from 8 seconds to nearly 30. CrewAI, on the same 3 concurrent runs, actually triggered the out-of-memory killer once, terminating the process outright. On a 1 GB box with no swap configured, CrewAI's heavier per-run footprint simply ran out of headroom. Add a 2 GB swap file, and it survived, but the latency was brutal. So what does this actually mean for your deployment? If you're on the absolute cheapest tier and running a single sequential agent, LangChain gives you more breathing room and a lower ceiling. If you love CrewAI's ergonomics, and it genuinely is nicer to write multi-agent logic in, budget for at least 2 GB of RAM, and configure swap as a safety net, not a crutch. The sweet spot I'd recommend for CrewAI in production is a 2 vCPU, 2 GB instance, which still comes in cheap, but stops the OLM killer from ruining your night. There's also a middle path worth naming. Run the heavy orchestration on your budget box, but offload the model itself entirely to the API, which both frameworks already do here, and keep your agent count low and sequential rather than parallel. That single design choice, sequential-over-concurrent, cut peak memory by nearly 40% in my tests, and it's the cheapest optimization you'll ever make. So the short answer is yes, you can deploy agents on a budget VPS, but the framework you pick changes your minimum viable hardware by a full tier. Tomorrow I'm putting both of these frameworks through a cost breakdown. Actual dollars per 1,000 agent runs, including the API bills that dwarf your VPS rental. So if you want that number before you commit your project to one framework, subscribe now and you'll get it the moment it drops.